Hello guys, welcome back to my YouTube channel techCodio. My name is Bharat Kumar. So guys, in this video I'm going to explain naive RAG application, which is the first RAG application which is came into the picture in the era of generative AI. So guys, in my previous video I explained simple and effective RAG application. That means passing the content to the model and asking question to get only the particular content that we are passing to the model. So there is no splitting, chunking, embedding and vector store. It's a pure RAG application. But in this video, we are going to see the naive RAG application using splitting, chunking, embedding and vector store and then retrieving. These are the 5 core concepts of RAG application. So this project we are going to do in this video. So guys, if you haven't subscribed to my YouTube channel, please hit that like button and also subscribe to my YouTube channel. Got it right? So guys, it is the flow diagram of naive RAG application. So let's see one by one. So first we are loading the PDF and then we are splitting and chunking the PDF and then we are embedding the document and storing into the vector database. So the retriever, which is going to retrieve the relevant content from this vector store based on the user question. And then after retrieving, we are passing it to the model and then getting the response. You got it right? So it is a basic flow diagram. So now let's understand step by step. Load the data. So here I'm loading the PDF, but you can load Word document or else you can give the text format also. So loading the PDF has completed. Let's assume loading the PDF has completed and then splitting. So we are going to split the PDF into pages and then into the chunking. So first we are going to split the PDF into the pages and then we are reading the text data from the PDF. After that, chunking. So in the chunking we have keyword chunking, token chunking, sentence chunking and then semantic chunking. There are so many chunking options, but here I have chosen the semantic chunking. So this chunking is going to done with the help of embedding model. So the embedding model is going to read the data step by step and then it is going to chunk it. So now let's see what is chunking in detail. So guys, assume that it is the original paragraph that we have. So here for example, assume that we have chunk size is 20 words and overlap is 5. Overlap means, so guys, this parameter is only for example, not fixed one. So here I have divided into the 4 chunks. Chunk 1. The world of artificial intelligence is vast and full of potential. From healthcare to finance, AI is transforming industries rapidly. First chunk is completed. In the second chunk, I have taken the half part of first chunk information to the second chunk. It is known as overlapping. So we are overlapping the content from chunk to chunk. So for example, we have retrieved only the 2 chunks, but there is no overlapping. So the model can't understand. So guys, you can see the sentence stopped here and then it is started from the previous chunk. So it is a continuation of this chunk. So the model can understand. So it is the continuation of the previous sentence. So that's why overlap is needed. Like that, same chunk 3. I have taken this chunk 3 from industries. See, up to this I put here. And then they are reshaping how we interact with the machines. And then the same content I have taken up to here, machines, and the extra content which will be added here. So it is a chunking process, dividing into the small documents. Assume that. But here there is no chunk size and there is no overlap because it is known as the semantic chunking. It is going to read the content and it is going to divide into the chunks. There is no need of chunk size and overlap. The model can do automatically. You got it right? So the chunking is completed. And then embedding and vector store. For embedding, I have used Hugging Face embedding model. And for vector store, I use the Facebook vector store. So here it is going to embed the chunks into the numerical format. As you all know what is embedding. So after that embeddings, I'm storing it to the vector store. So when I want, I can retrieve the relevant information from that vector store. And then retriever. So it is a core concept of this RAG application. So when a user enter a question, it will go to the embedding model. It is going to convert into the numerical format what we embedded. It is going to identify the top 3 similar documents or chunks from the vector store and then it will convert it back to the text format and then we are passing it to the llama 3.2. So the llama 3.2 will give the answer. So in the prompt, we are passing our question and the retrieved content. So now understand, in the prompt template we define answer the question based on this content. So it is going to read the question and then it will read the retrieved content from the retriever. So finally it will try to give you the response based on the question. So it is the naive RAG process. So guys, I hope you got the clear-cut mind map of NiveRag application. So it is a PDF that I have been using in my all videos, because if you want to give any data, you should aware of the data, what is there in that PDF. You have to understand how much content is there. So then only you can able to identify whether the model is giving it from the PDF that you provided or it is using its own memory. So guys, it is important point. You have to understand about the data what you are giving. Then only you can able to verify the content is coming from your PDF or not. So guys, in my previous videos, I explained how to run ollama models in this Google Colab. So guys, if you haven't watched that video, please go and watch it out. So guys, in that video, I explained in detail. So in this video also, I explained how to download ollama models. But if you stuck here, please go and watch that video. So first, we need to install all these packages. So meanwhile, I'm going to upload one PDF documentation, data science PDF. You can see the PDF is uploaded and the package is also installing. So guys, installing the package is completed. So guys, now with the help of this PDF plumber loader, I'm going to load my PDF. After that, so first I have initialized my loader and then docs equal to loader.load. So it is going to load the PDF. Now I'm going to see the number of pages, length of documents and number of pages. So guys, now I'm going to see the length of documents. I mean how many pages are there. In the PDF, you can see here there are 37 pages. So with the help of this package, we can able to know there are 37 pages are there. And then here I'm retrieving only the doc2 data. It is a doc2 data that we have. Now we need to install this sentence transformer. Now from the LangChain experimental, I'm installing semantic chunker. And from the LangChain embeddings, I'm installing my Hugging Face embedding model. It's a small embedding model. Text splitter equal to semantic chunker. And then I have added Hugging Face model. After that, documents equal to text splitter dot split documents. I'm passing these documents that I loaded here. So guys, you can see the Hugging Face model is downloading. See, we have initialized splitting also. Now let's see how many chunks are created. You can see 74 chunks are created with our 37 pages content. Now here I'm going to view each and every chunk. See guys, these are 72 chunks that we have. Chunk 1 data, chunk 2 data, chunk 3 data. Like that we have 72 chunks. Now creating embeddings. So guys, you can see here whatever embedding model I use for semantic chunking, the same model I'm using here also. Embedder is defined. From LangChain community vector stores, I'm importing FAISS. It is a Facebook vector store which is given by the Facebook company. Now vector store equal to FAISS dot from documents. I'm passing the documents. In this documents, the chunks are there. 72 chunks are there. And then I'm adding my embedding model. See now, embedding is going to happen. Embedding is completed. Now let's print embedder and vector. Embedder and vector. Now retrieval from the vector store. So guys, now we have to define the retriever. Vector dot as retriever. So the FAISS is giving the retriever also. As retriever, search type equal to similarity. So we are going to identify the similar keywords which is there in the vector store. Search keywords equal to, I'm going to give the 3. It is going to retrieve the top 3 chunks from the vector store. Retrieve documents equal to retriever.invoke. In this invoke, I'm passing this question. It will go to the model, try to find out the similar embeddings, and then it will convert it back to the text. Let's run it. It has given the content. Now we need to install this Colab XTerm. This package help us to download the llama model from the ollama. Here guys, you have to copy this and paste it here. But I'm unable to copy. I don't know why. Copy is not working here. I'll type it manually. https ollama.com install.sh See, it is installing ollama, installing and downloading Linux bundle. So guys, you can see the downloading is completed. So before that, you have to set your runtime to T4 GPU. Please don't forget to do it. Now next is this command, ollama serve ollama run llama3.2. See, sometimes it will give like this. You need to stop this terminal by pressing Ctrl C and then execute the same command again. Error, it's already in use. So now let's define our LLM llama 3.2 model. So guys, you can see we have defined llama 3.2 model. Now the next step is we need to set a prompt. In this prompt I'm passing use the following pieces of context to answer the question at the end. If you don't know the answer, just say I don't know, but don't make up an answer on your own. See guys, I'm giving the instruction to the model. Don't make up answer by own knowledge. Keep the answer crisp and limited to 3-4 sentences. Context equal to retrieve context, question equal to question, and then helpful answer. Now here I'm making it QA chain prompt. Prompt template, from prompt template I'm passing my prompt. So this prompt template is going to, we can give directly this context, but we are using the framework. Now LLM chain. In the LLM chain I'm passing my LLM model and then my prompt template. That's it. Verbose true, callbacks equal to none. LLM chain will be printed here. Next is document prompt. Prompt equal to input variables, page content and source, template. So this is going to tell us from what is the source and what is the content and then what is the name of the PDF. Document prompt, it is going to give us. So here LLM chain I am passing which contains LLM and document prompt. Document variable name is context, it is a context variable name. Document equal to document prompt, which will give us the input, how many inputs are going to the model. Combined document. So this combined document I'm passing it to the retrieval QA. So guys, the lang chain, the name itself is saying chain. So here we make 3 steps of chains. In the first we have, here we give documents chain. In this we have LLM chain. In the LLM chain we have LLM and prompt. In the QA prompt we have prompt, and then in the LLM we have llama 3.2 model. We are putting all it together into the retrieval QA, which will done the process. So now in the retriever I'm passing the retriever. So the question which is passing to the QA, which will go to the retriever, get the content and then pass it to the model. Let's run this. You can see LLM chain, document input variables, page content source, and then combined document LLM chain, verbose, like that. It is the parameters. Now I'm going to ask this question. So in the previous video also I asked this question only, but now also I'm going to ask this question only. So guys, you can see it gave the response, we got the answer. Now let's see here step by step. Entering new retrieval QA chains, entering new LLM chain. So in this retrieval we have LLM chain. So guys, in this retriever we have LLM chain. In the LLM we have prompt template and then LLM model. See guys, you can see it is our prompt template. We gave it in the prompt. Context, it is the, in the retriever we said top 3. So it is going to retrieve only the top 3 content. It is the first context and then first context sources. From where it is coming? It is coming from the datascience.pdf. Second context and then third context. Chain is finished. Here is a concise answer. So the model gave this answer. So it is a prompt template guys. From here to this green color is known as prompt template, that which is passing to the model. So the model gave this answer. Underfitting occurs when a model is too simple, resulting in high bias and low variance. It fails to capture underlying relationship in the data and performs poorly even on the test data. On the other hand, overfitting happens when a model is too simple, leading to high variance and low bias. This results in poor performance on both training and new unseen data. So guys, it is the exact answer. It is a concise answer that we got from the model with the help of documentation. So the retrieval will go to the document, will go to the vector store. The vector store we have chunks. The chunks are coming from the document. So it is going to identify the similar words. So with the help of embedding model, it is going to identify the similar words. That's it. Only that content we are passing here. So now let's set the retrieval to the 5. Let's run this again. Now let's see it gave 5 or not. First one, second, third, 4, and then 5. And therefore we have so much content. See, it answered same. But the problem is, let's understand the problem with retriever. It is retrieving the top 5 nodes. But here we want the answer, but our answer which is there in the first and second only. But 3, 4, 5 documents we are passing extra to the model. So the model may hallucinate. Sometimes we give 5, but our question needs 10 documents. So the model has only half knowledge to answer the question. So that is a problem with the retrieving concept. And with the chunking also we have so many problems. That's why I use the latest one, semantic chunking. But recently we got one more chunking which is known as late chunking. It is also advanced concept I'm going to include in these videos. But it is a naive RAG application. We have so many disadvantages with this. Coming to the embedding model. So here I use the simple embedding model. In order to make it effective, we need to go to the best embedding model from the OpenAI. Like that. For example, vector store. It is a simple vector store. It can offer only the similarity search. But there are some amazing vector stores we have. Milvus, Pinecone, which will support us hybrid search. In that hybrid we have semantic search and similarity search. Semantic means it is going to identify the meaning. Similar means based on the keywords. That's it. Retriever also. For retrieving also we have so many retrievers. Right? So these all are the problems. And here I use llama 3.2. We might use GPT-4. It can give better answer. So for each one we have some disadvantages. So the people are still facing the problem. So recently we got best RAG applications. One is graph RAG. After that graph RAG we have light RAG. So the process is evolving step by step in the generative AI. So we need to learn each and every step from scratch. I mean we need to know the history. It is a first RAG application.